Good evening and welcome to today's session of Saturday Talk by JanyuTechnologies. Today we have Professor Dr. Arvind Singh for today's session. A brief introduction of Professor Dr. Arvind Singh. Professor Dr. Arvind Singh is an assistant professor grade 2 in Department of Physics, Guru Nanak Khalsa College, Mumbai. He's completed his master's in science as well as B.Ed. It's qualified CSIR NIT exam. He's been awarded PhD from Reputed Institute of Chemical Technology in Mumbai in Physics, Nanomaterials. On his work front, he is currently assistant professor with JN Khalsa College, which is affiliated to University of Mumbai in Physics department at degree level from the year 2013 till date. He's been a visiting faculty in Department of Bioelectrical Sciences in JN Khalsa College from the year 2013 to 2016. He was a full-time lecturer in Thakur College, Junior College, University of Mumbai for the year 2005 till 2010 in Physics department. He has also worked as a scientific assistant C in National Center for Nanosciences and Nanotechnology, University of Mumbai from year 2010 till December 2011. He was working as a research fellow under UGC grant for SAP fellowship at University Institute of Chemical Technology in Matunga, Mumbai. His current research work on wastewater treatment and energy materials by experimental and computational methods. So far, he has published more than 25 papers in International Journal of Impact Factor and High Repute. He is actually involved in teaching, learning novel methods and techniques. He has been regularly invited to talks in several conferences and gets as a guest lecturer. Recently, he is awarded a Master Trainer certificate from Maharashtra State Faculty Development Academy, that is MSFDA. Also, Maharashtra State Development of Educational and Enhancement Delivery and Program in MSD Level 2. He has in-person Master Trainers Workshop on Effective Training Program, and today is going to speak on the topic that is thin films and its application, that is Viksit Bharat at year 2047. Over to you, sir, from here. Thank you so much.
My today's topic is thin films and its application, and this will surely give us a good support to leap in the future and attain our mission of our government, Prime Minister Narendra Modi ji's and our peoples of being Viksit Bharat at 2047, that is Amrit Kal, will complete 100 years of independence. This is my college. I come from Guru Nanak Khalsa College, one of the oldest college in Mumbai. It was established in 1935. At Guru Nanak College, we have multiple departments, and there is multidisciplinary education and research. And what we focus is for long-term goals and address challenging problems in material research, we focus on education of students for future scientists, knowledge transfer and networking, creation and distribution of useful tools for research applications. And in this scene, currently 10 to 12 students of our college from Matunga are currently right now in Vasai in one surface coating technique. They are doing on-job training. So you can see we are promoting the students, motivating the students to come all the way to Vasai from Dombili, Bhandup and other places to work into research and industry-based programs. So we focus on collaborating network thrust, knowledge sharing and materials computational tools and algorithm thrust. Okay, so when we talk about Viksit Bharat, so we have to always remember from where we have come. So these are few pictures of 1947 when India got independence, and we can see our first Prime Minister Pandit Jawaharlal Nehru addressing the country. And over the period, we have come a long way from just being someone whom foreign countries were saying that they will not be able to even make a needle. And from that, we are now progressed to being the nuclear power country and also having a lot of technological developments. And obviously, this picture says 1,000 words. I can say this says a lot of things, like, how we started our space mission. And now we are into the top cream countries being in the space missions. These are few our India's projects of space missions. And now what we are looking at, these are certain things on the screen which you can see, like GST. India has come to a point where it has decreased GST, our current government and our Prime Minister Modi ji. And also one of the picture you can see there are some chips, ICs, and then there are some girls, or there is a girl who is having some dreams, the dreams to fly, dreams, and behind that you can see farmers, you can see farmlands, so all these are connected. So when we will achieve all that together and progress, and then we will say that we have developed India mission or Viksit Bharat Abhiyan 1947 to 2047. My country will look something like this if we attain all the goals of Viksit Bharat and if we get developed. So it will be more sustainable living. And one of the things which we have already achieved is Digital India. Our UPI is famous over the world about it. There are certain points regarding just one slide about Viksit Bharat, like what is the basic focus of Viksit Bharat 2047? It's like startups. So there is an encouragement and support to the growth of startups to drive economic progress and job creation. There is also push to research and development, that is to foster innovation and advance scientific and technological capabilities. Deployment and adoption. So it is a program of implementation and widespread adoption of advanced solutions to transform industries and society. There is also a big push to tech and innovation. So this will focus on transformational tech and innovation like AI to boost efficiency and output. Infrastructure development, so world-class infrastructure to support sustainable growth and improve quality of life of citizens. Enhancing skills and capacity. So it will equip the workforce with the necessary skills and knowledge to thrive in the future jobs. So currently I am sitting in Vasai West and JanyuTech is in Vasai East. Just within this 5 to 10 kilometers, there is a vast development, and the biggest development which is going to run is the bullet train. So we can see our country is moving towards getting to this Viksit Bharat goals. As today's topic is more of thin films and its application, so there is a few glimpses of these images in which we can see a film is whole and there are different colors on the films also. And below that there is one image in which it is a deabsorption, nucleation, absorption. These are types of thin films mechanism which we are going to discuss. So what are thin films? So thin films are thin material layers ranging from a fractions of a nanometer to several micrometers in thickness. So there is one thing is called as substrate and another thing is called as deposition. Or that deposit material will be forming actually the thin films. So thin films are thin material layers, as I said, ranging from nanometer to several micrometers in thickness. Ferromagnetic thin films are used as a computer memory, right? The relatively high hardness and inertness of ceramic materials make thin coating for protection of substrate materials against corrosion, oxidation and wear. So these are the different places where thin films are used. The use of such coatings on cutting tools especially can extend the life of those items by several orders of magnitude. Right? Cutting or drilling tools. The coating is very important. Now, to achieve all this, we need to deposit the thin film. Thin film deposition is a technique for depositing a thin film of material onto a substrate or onto previously deposited layer. So thin film deposition can be on a substrate or it can be already deposited layer. So we can have multi-layer deposition also. Thin film is a relative term, but most common deposition techniques allow layer thickness to be controlled within a few tons of nanometers, and some allow even single layers of atoms to be deposited at a time. Now the example of the later one, like single layers of atom or few layers of atom. Now this computer chips, or we can say the processors like i3, i5, i7, and now the latest one, they are deposition now not of nanos, they are now being deposited at Armstrong level, 1 by 10 raised to 10, that is 10 to minus 10 level. Forget about nano. Now the technology have moved into the Armstrong level, right? And depositing that thin layer gives more efficiency or more power to the processor. So if we compare of thin films with the thick films, so this image shows us gives us little bit more idea. In bulk or in a bigger thick material, thick layer, there are atoms in 1 centimeter cube around 10⁻22 to 10⁻23, right? And when it comes to thin films, so thin films basically will be 2-dimensional. Bulk films will be 3-dimensional. So thin films will be 10⁻15 to 10⁻16 atoms only as compared to the bulk one in 1 centimeter square area. So what will happen? Light reflecting from a thin film, you can see this, right? Burst of light few micrometer long. These waves reflected from the two surfaces are part of the same burst and coherent. So you can have more interference here, or the phenomena of light materials will be different, and that is why you can see different colors. We'll discuss about this more. Whereas thick films, the waves reflected from the two surfaces are from different bursts and are not coherent, right? Since the thickness is very less, mostly they will be coherent, and these are non-coherent. And that is why the beautiful colors which we see on the glasses and on all the different things, they are because of thin films and its interaction with the light. Okay, so if I compare image comparison, so you can see, first of all, sheets or plates like, around 1000 micron or 10⁻³ or millimeters or centimeters. So these will be sheets or plates, and we'll have thick films like foils or a plastic, and then comes this range where we call them as a thin films. If we further go below micron level, nano level, then that will be atom or atomic layers. Why these thin films are so important? Now, deposition of thin films on solid helps to improve their surface properties. In this manner, forming a thin film on a bulk material is used to obtain the desired mechanical, electrical, or optical behaviors on the bulk material surface. So these properties can be achieved differently, or all of them can be there, thus achieving exceptional features such as higher conductivity, higher or better corrosion resistance property, good reflection or required reflection, and hardness on the surface. So the current market, generally I have few slides here now of market, like what is the global positioning or Indian positioning on the thin films. Generally, we academicians keep this at the last of the presentation, but knowing the participants or this group who is attending this lecture more business oriented, so I choose to keep it in front. So the current market for deposition techniques include chemical vapor deposition, in which the chemical is heated or there is chemical reaction and vapors are generated and they're deposited at the top of certain substrate. Or we can have physical vapor deposition. Physical vapor deposition means the material is heated or it is sputtered or high energy beams are incident and that material evaporates and gets deposited. So the current market has these two basic techniques, CVD and PVD, but in this one, PVD is more into the application part of industry-oriented things. Now, the global market for CVD market is estimated to value around $26 billion in 2025, and it is expected to reach $49 billion by 2034. You can see it is almost doubling in just 7 years. It is going to double. The global PVD market is projected to reach 49.2 billion by 2033. Now, Indian market, India is gaining traction as a rising market in the Asia Pacific for CVD and also for PVD and ALD. And this is driven by growing electronics and automotive production. And the best one to say in this one is like, Make in India and Digital India. And now what we have is the first chip company which has come in Gujarat of CG Power. You can see the India is now in the perfect position. Thin film coating market is set to reach 32 billion by 2030. So the key drivers for the thin film market is increasing demand for advanced semiconductor devices, growing adoption of CVD and PVD, which I just mentioned that. Now India is manufacturing more PVD and CVD machines, right? Technological advancement in deposition techniques such as ALD, PVD, and government support and initiatives for promoting domestic manufacturing and innovation. What are the key factors that influence the thin film formation, or what are the factors which are important we should see when we want any application for? Suppose we want a robots which have a coating, which have a surface which will be taking Wi-Fi signals even higher temperature like 400 degrees Celsius or 700, 800 degrees Celsius, and we want that robots to even not fluctuate much in the Wi-Fi signal or in other thing. Plus, we want them to be strong and all. So, what are the key factors which influence the thin film? So, one is layer thickness. Control over individual layer thickness, typically in the range of nanometers, will give you the required application of the thin films. Interface quality. Now, substrate and the material which is to be deposited, they should have a good interface quality. So it will minimize the defects and roughness at the interfaces between the layers. Material selection. Choosing materials with desired property and compatibility is important. Now, for example, we want some for example, take fan. So nowadays fans are coming in different designs and a lot of fancy fans are coming. So if someone wants like, silver coated fans. So if we coat the silver on the blades of the fan, so if the thickness is more, so there is a chance of there will be erosion, or you can say corrosion, or the layer will get sputtered or removed out slowly, and then it will turn out black. So one of the solution can be to deposit nano layer silver film, so that silver color will come and there will be no much this silver layer getting damaged or the particles coming out. So there not be much blackening, and also since layer is thin, material is less used. So such silver, gold, platinum coated materials can be easily made by this thin film coating technology. Deposition conditions like temperature, pressure, precursor, all these are important factors which are responsible for thin films. So thin film technologies like, you have substrate and then we have thin films, and material application can be intercalation. You can prepare intercalation material, or it can be electronics, or it can be optical. It covers a wide range. The first evaporated thin film as per the literature was prepared by Michael Faraday. in 1857, right? In around the same year, he also made some silver nanoparticles, so which were also the type of thin films also. And in 1946, there was a development of vacuum and first industrial application during the World War II. And there was iron plating done by DM Methods, which was done around 1963. So you can see it is just a matter of 1980 to 2025. We are just 40-50 years. It is too much, but still very close. But you can see the application, or you can see the increased demand and increased market availability for these thin films. 1980, physical vapor deposition techniques was used for jewelry. Rise of gold prices were high. So what happened? So they started coating gold, and coating cannot be like we are painting the walls and all that. So they have to be very precise coating. A vacuum is created and a material is evaporated. That material goes and deposits atom by atom, right? So also in 1990 around, there comes multi-layer engineering. Now this is the main, unique, you can say USP of thin film thickness of multi-layer engineering. We'll see that. So this is the trend, how the things have developed. Nanoscience is the ability to understand, create, measure. So we use a lot of knowledge of nanoscience and then nanomaterials in this thin film technology. There are already the commercial applications of this nanotechnology or nano thin films, like, these are the nano care fabrics. So these, if you throw water or oil on that, they doesn't get absorbed, they get spilled out. They are hydrophobic. Even nanoparticle skin creams are also used. Now, not even tennis, even badminton rackets are also coming with graphite or graphene or carbon nanotube rackets, which are strong and more easy to play or better. So just a DY paint on coating for energy efficient windows. So researchers are developing a polymer based heat reflecting coating that makes use of unusual molecular architecture of polymer surface. So these layers of materials, polymer based reflecting coating, will be of very thin, or they will be of nano or micron layer. And why they should be thin layer, we'll discuss that later. This is one example of nanoscale wires that can serve as a tiny tunable laser. This is just a wire. Excellent performance for field of optoelectronics, which is focused on combining electronics and light to transmit data among other applications. This is just an artistic view. So, but when we use nano sponges that fight climate change. So what are nano sponges? They can capture carbon from power plants before it enters the atmosphere. So it is basically a hybrid membrane composed of nano-sized cages called metal organic frameworks. So this will metal and oxide metal particles. And a polymer is 8 times more carbon dioxide permeable than membranes composed only of the polymer. So this will be 8 times better permeable membrane. So more and more CO2 can get absorbed. Boosting carbon dioxide permeability is a big goal in efforts to develop carbon capture materials that are energy efficient and cost effective. And such metal oxide frameworks or such hybrid composites can be painted along the roads or in different portions, and even somewhere around the factories and all, they can be painted. This is one of my favorite slides whenever it comes to nano or thin films. In 1959, Sir Richard Feynman sir has said that there is plenty of room at the bottom. In 1960, there was no application of nano things and all. But that idea was there that nano will work better. Nano materials can be made 2 ways, just like we have our Elephanta cave. It has been made from big stone to small carving. And another one is our gate of India, which is made brick by brick. So same way, nano materials can also be made from top down approach or bottom of approach. Means from small atoms, we can make them a nano material, just like Gateway of India, or from a big material, we can keep on crushing, heating or doing processing, and we can break down it, just like Ajanta. So when the material becomes nano, so it's not about just a nano material, the same implies for nano thin films. That is why I'm coming to all these points. So even the same material in different forms, nano forms, different sizes, they will appear to be different colors. So why it happens? It happens because there is a quantum confinement. In nanocrystals, the electronic energy levels are not continuous as in the bulk. But when you take a bulk material or a bigger material, there are so many atoms. So what will happen? The energy level will be continuous. Whereas in nanomaterials, there are less atoms, less electrons. So the energy levels are discrete, less energy levels, because of the confinement of the electric wave function to the physical dimension of the particle. This phenomena is called as quantum confinement. You'll better understand in the next slide. For example, we have this electrons confined in one dimension. I was talking about quantum confinement. What happens? Like if you have a 3D or thick layer, so the electron is not confined anywhere. If you have a thin layer, nano layer, then the electrons, or there is a quantum well type structures which are formed. So these will have only in 2 dimensions, right? And when we have our carbon nanotubes or hair-like dimensions of micron level nanomaterials, we have 2 dimensions. When we have single 1 nanomaterial, so it has a 0 dimension confinement. So it is confined in all the directions. So we have restricted it. So we have control over the film's application and properties. The best material to talk about when we are talking about thin films is Crizal lenses. Crizal lenses, if you go for a Crizal lens specs, good quality will cost around 20 to 30,000 minimum. It comes in lower cost also, but a good quality, average quality is 15,000-20,000 Crizal lenses. What makes them so special? There is no glare. So this no glare treatment comes from different layers of the Crizal lenses. So if we see the full lens, there are multi-layer deposited on them. So if I see from this portion to this portion, the top one, you can see the front side of the lens, and then we have back side of the lens, and so many thin layer of coatings are done on that. So there are many, like anti-reflecting layers with UV reflection protection. Then actual lens is here. You can see the bottom, second last bottom, actual lens, which gives us the appearance, the defect in our eyes that removes that lens. Then we have 2-sided scratch resistance layer, SR booster, anti-reflecting coating. We'll see that in the next slide. So the first image with ordinary lenses, if we don't see the bottom one, we'll find the first image is good. But the moment we see the second image, we find it is more clearer. No doubt, there is a difference between the model who is appearing in the lens. I'm not saying that how it is appearing to us, but you just see her specs. I'm talking about her specs, not other portion. Her specs, the first one, you can see there is a whitish line, which is glare. And when they put Crizal lens, there is no white lines on the specs. The image is only about the specs. So you can see at the top, first one, there is a white line, so which is glare, and because of which there is no clarity. But in Crizal lenses, the clarity is very clear. So what they make, so they have automated lenses, stripping and cleaning. They have application of scratch resistance layer. So this layer doesn't gives any scratches. So it has more life, and it comes only when we coat a material which is more flexible and strong and durable. Then preparation of lens surface in vacuum coating machine. They prepare this in vacuum coating. Now vacuum can also be different level. How much vacuum is created? To get a very good coating thin films, you need a very good amount of vacuum, which has to be. And I have the data later on how much we want. Then we have this SR booster layer. This proprietary scratch resistant silica glass layer is added between the hand coat and anti-reflecting layers on both the front and the back side of the lens. This is their patented, and then this already we have discussed. So just imagine in this one lens which we wear, there are so many coatings. So what requires precise coating technology is required. For the aerospace industry, hydrogen fuel cells, everywhere coating comes into this, then window panes, and Apple Mobile. Now Apple has going to make its manufacturing hub in India. So lots of, now these colors of the Apple, of the front one, they comes only because of physical vapor deposition. So there will be requirement of around, around 300 to 400 physical vapor deposition machines. One single physical vapor deposition machine comes around 20 foot by 20 foot area it takes. And it is around 12 to 15 foot height, 10 to 15 foot height. So imagine so many physical vapor deposition techniques or machines are going to be installed. These colors, different colors comes only because of precise coating. Now thin film transistors, monitors, amorphous silicon, shrinking of computer. Now most of you are engineers, or most of people know about why the computer has shrunk, because of the development of chips. Electron beam evaporation, physical vapor deposition technique. This I was talking about. So there is the target which is to be evaporated, and these are sample holders. These are sample holders which are kept. So the material will get heated or by different phenomena, and then vapors will come and get deposited in it. So as I have already discussed many applications of them, thin film deposition, these are the chambers, like plasma deposition is also there. So you can have physical vapor deposition or chemical vapor deposition or plasma deposition also. So these are different thin film deposition techniques, physical one and chemical one. The chemical one is spin coating, means you spin a substrate and you coat something so it get absorbed. Spray pyrolysis, dip coating, CVD method. And physical deposition are these. PVD method. It can be thermal, pulse layer, or it can be in situ laser assisted, ion beam assisted, electron beam assisted, and all that. So these are some thermal evaporation technique. This is the material which has to be evaporated, and this is the substrate. And a pressure is maintained into this. This is laser, pulse laser deposition. So you put a laser, high energy beam laser onto the material. So the material sputters them or removes them one by one. Again, a physical vapor deposition simple diagram. This is how it looks. The small one. This is just a small portion, 1/10 portion. If you take a proper, it will be around 10 feet or 8 feet, 10 feet long and 100 by 100 feet. There are vacuum gauges, main pump, in situ analytical tools, substrate manipulator. You can manipulate means you can change the temperature and all other things. So these are types of PVD: flash evaporation technique, chemical vacuum technique, sputtering, and ion beam assisted. This is technical complexities, right? High production cost and scalability. We are talking about thin films or something like that. So we need to have high production cost, and also we need to have scalability of it. Material and regulatory concerns, right? Now, for example, CDT materials, which I said they are carcinogenic, so there is a problem. Then competition, thin films face competition from traditional materials like crystalline thin film solar cells and all. So these are some challenges, but we can overcome by making a perfect structure. Now, what are the more challenges to us? Now, recently, this is not related to thin films, but recently fertilizer costs are increasing in India. And one of the reasons is China has banned exports of fertilizer and few important ingredients required to make it. And China has also implemented ban on US, but that is regarding its defense sector. China has not banned directly to India, but indirectly it is affecting us. So India's economic grew. We have number of elements fixed on the periodic table. They cannot increase, right? Recently, I had attended one lecture of this Umesh Matresa. So he told me about this. The number of elements are limited. They are not going to increase. So chemists have no role now to increase the number of elements. Even manipulation of materials is also maximum done. Now many elements are going to be banned. They are going to be banned from different countries and all. So what we can do is we can develop the technology to make the thin films or different structure films or multi-layer films to get certain applications. So we are expecting our economy to grow. Global economic growth projection for 2025. India is a growing market, which I meant to say. So we should focus more on made in India, and we should lead to this Viksit India, the bold vision, brighter future of 2047. Thank you.